So today I want to introduce you to Python 3. And I assume that some of you might have not seen Python at all. So I will kind of give a very easy introduction, but then I also want to move to some more advanced topics. So in particular, we'll also talk about classes and some special functions that we have in classes. But before we go into the details, some updates. So remember that today is the deadline for assignment 2, today at midnight. So make sure that you've pushed your solution to your private repository in the GitHub organization. You do not have to upload anything to Develry. I had multiple questions. So since last year, they changed the Develry system, and so now by default, it asks you to upload stuff to Develry. You don't have to do that. As long as your solution is on the GitHub repository, you're fine. And then, of course, it can happen that you become ill, or So in that case, you can go to the course web page. If you go onto the link Opgave, you find a Google form where you can fill out you ask for an extension, your username, and then the reason, and so on. And so typically you'll get a 3-day extension you get granted without any questions asked. But if you want to have a 7-day extension, there you need a sheet from the doctor saying that you're actually severe sick. So then assignment 3. So this is this week's assignment. That's online. Both the mandatory assignment and the group assignments are both available on the website now. Then regarding group sessions this week. So all the group sessions are as normal. Only group 3 is cancelled today. So that's the one today from, I think, starting at 12 to 2. But anyway, there's a group at the same time. So you are free to go to the alternative group or just go to any other group if that fits you better. And last but not least, regarding lectures, there's no lecture next week. And in 2 weeks, we will dive into more advanced topics in Python. So we will talk about numerical Python. Good? So let's start with, I don't want this. Let's start with Python. So before we can start, we of course need to install it. And there's many different ways on how you can get Python on your system. In fact, it's quite likely that you already have a Python installation on your system. The only thing you have to be aware of is that this course is based on Python 3. So if you have a Python 2 installation on your system, you might have to install Python 3 in addition. And the way you can do that, or one easy way you can do that, is to install the Anaconda distribution. So Anaconda is essentially a installer that installs Python and a lot of additional packages, if you want to, on your system. And you can install this locally. So essentially, it's part of your user installation, and you can just remove the Anaconda directory one if you don't need it anymore, and then the installation is gone. So why do we recommend Anaconda? So it's completely up to you, but I often like using this Anaconda distribution. So one advantage is that it's a local installation. It has a package manager with loads of packages. And I'll show you in this instance how you can install new packages. Then it's available on all main operating system. And I've also described how you can install Anaconda on an EFI machine if you're doing your exercises on an EFI machine. So here's a quick guide how you install it. So of course, you just follow the installation instructions if you go to this website. And then I typically want to use it as a local installation. So you can install it globally so that it's available for all users on the system. But that's, for instance, not possible on the EFI systems. So there you have to make sure that you install it only for you as your local user. And then what you want to do is you just type in the command python ---- version, and then you'll see if everything is installed correctly that you should see a Python number 3, so it might be 3.6, or and then here this continuum analytics just indicates that we're using the Python that comes from the Anaconda distribution. So here's how how you can install new packages in Anaconda. So essentially, Anaconda is like the app store for Python libraries. Right? So what you can do is you can search for, let's say I'm interested in a package called SciPy, which does scientific Python. So what I can do is I just type in conda search SciPy, and then I get a list of packages that are related to SciPy. And then I can install this package by using the command conda install SciPy. And then if I'm interested in which ones have I installed, you just do conda list. And so you can update packages, you can remove packages, and so on and so forth. Okay, and of course, one important aspect is how do we get help if we are stuck. So in general, there's extremely good online documentation. So in many cases, it's actually a smart thing to just Google your problem. But there's also some more structured ways on learning Python. And so I've recommended 3 books here that are specific to Python 3 that I think are quite a nice introduction. So these are all links that you can just use when you open the slides. So then in addition, one resource that I often use in practice is the built-in documentation. So essentially, every function, any module, and any class in Python has a built-in documentation, and you can access the documentation by using the pydoc command. And so the way it works is you type this into your terminal, you just type in pydoc, and then let's say you want to know the documentation of a module, or you want to, here in the second example, you ask for the documentation of a function inside that module. So I give you an example. So if I'm interested in this command sys.exit. And so what I do is I just type in the command pydoc sysexit, run it. And so here you get a detailed information about, right. So here's an example usage. Here it tells you what it does, and so on and so forth. Right? And so that essentially works for any function in Python. And so you can actually also write your own documentation for your functions. And I'll show you in a second. I'll show you later how you do that. Right, so let's get started. Let's look at our first Python program. Here it is. It consists of 5 lines. And before we actually start dissecting, we will go through every line in a second. But before we do that, the first thing that we can do is we can just save these lines in a file, for instance, hw.py. And so for Python programs, we typically use this ending .py to indicate that this is a Python file. So you just save this text in a Python file, in this .py file, and then we can run it. And the way we run it is by typing in the bash command Python, then the script name, and then potentially additional arguments that we want to pass to the script. So in this case, we pass 0.8 as an argument, and then we see the output. And you see that it prints out hello, and then sinus of 0.8, and it does some calculation, actually shows us what the sinus of this number is. So alternatively, and you've already seen this, this is very similar to what we do with bash scripts. We can also make this hw.py file executable. So remember, last time I explained to you this chmod command where we called chmod a plus x and then the script name, and afterwards it was executable. So after we've done this step, we don't need to explicitly use this Python command anymore, but we can just use /hw.py and then the argument again. So these two are equivalent, and And so in practice, if I use the script more often, I often make it executable so that I don't have to type in the Python interpreter name every time. So now let's dissect the script, and let's go through it line by line to see what's going on. So the first line was this started with #user bin env Python. And so this is a magic line, just like the magic line that we had in Bash. Remember, we also, here for Bash scripts, we often used #bin bash, right? And that described, that indicated which interpreter should be used for the script. And so exactly the same is happening here. So we're telling the script with this magic line that this is a Python program. So the next two lines were import statements. And so what these are doing is we are importing additional functionality in our program that we will use later on. So specifically, what I'm importing here is the sinus function from the maths module. So the syntax for that is from math import sinus, right? And so I looked up the documentation of the math module and found, aha, there's a sinus function in there. So that's how I ended up with this line. And then we also import the sys module because I want to exit. So the sys provides an exit function that I want to use in a second. And it also, in this case, it actually provides access to command line arguments, which I want to use. So now we're done with importing the functionality. So the next step is to read in the value of the first command line argument. Remember, we passed a number as a command line argument, and so that's what I need to extract now. And so the way we do that is we use this sys.argv command. So sys.argv gives us an access to all the command line arguments, and then I extract the first command line. Actually the indexing starts at 0, so I extract the second one. The first one is always the script name itself, and the second one is the first real command line argument. Right, so I get this out here, and then I pass this into this float function. And that does a conversion. So the command line arguments are always given as a string, and I do an explicit conversion to a floating point value, because I know later on I want to compute the sinus of that value. And so then we store the result in this variable x. Right? And so just as a note here, I don't declare which type this x is here. Right? I can just write x equals something, and then automatically Python will know that x is a float. Yeah?
So a minor point, but you should specify which version of Python you're using in the shebang line, whether it's 2 or 3.
In the command line?
In the first line.
In the first line.
Right.
You could have written Python 3 instead of just Python.
Right. So that's actually a good point. So So I assume that your installation, well, if you go all the way up here again, yeah. Okay. So when you've installed Anaconda, that will actually, after you've installed Anaconda and you type in Python, that will automatically launch the latest version, so Python 3. But sometimes you might have Python 2 and Python 3 installed at the same time, and then it's important to state explicitly which version you mean. So what you then can do is you can just type in Python 2 or Python 3, right, to make that explicit. So let's go back to that, and that is also true up here in our script. But I could have written user bin env Python 2, or in this case, actually, I want Python 3 to explicitly state that this should be run with the Python 3 command line. Thanks.
Well, basically, Python is just a link to Python 3 in your case.
Yeah, that's right.
But it could be a link to Python 2 instead, and then you would run Python 2.
So then the final line in our script was a print command where we printed out the result. And the way this works is that we use this print function, and as an argument we provide the string that we want to have printed out. But of course our string isn't a fixed string, but we want to have some string substitution in there, right? And so remember we said the output was hello sinus of, and then in here we wanted to have the value of the command line argument, right? And so these curly brackets, they're just placeholders in Python. So there's one placeholder here, and then I have equal, and then there's another placeholder here. And the way I actually insert now values in this placeholder is by applying this format function on the string. So I call dot format, and then I say x should be, so the value of x should be put into the first placeholder, and the value of sinus of x should be placed into the second placeholder. So that's how it works. And so we could extend this even, and instead of just specifying the placeholder, we could provide more formatting arguments on exactly how the string should be formatted, right? So remember we're passing in a floating point value, so especially if you think about the sinus of x, right? So that had a lot of digits after the comma. So if I wanted to cut this off to only show 3 digits after the comma, I could specify exactly how the numbers should be formatted. Yeah. Okay, so that was our first script. So now let's go a little bit more in detail through Python. And, well, the first thing that you might want to do is to use Python as a calculator. And so doing that is very simple. So what you do is, once you've started the command line, the Python interpreter, you can just type in your formulas as usual. So just one thing to remember is if you want to compute the power of something, so for instance, 4 to the power 5, you use this double star notation, right? That means to power. And so as you can see, there's kind of the standard operations are already available when you launch Python. And then, as we've seen before, if you want to use more advanced mathematical functions in Python, we need to import that functionality. And the way we do that is for instance, we use this math module, and let's say I'm interested in the 10 logarithm, so I can write from math import log 10, and then I have that function available, and I can compute log 10 of the number 5, and I get the result out.
There's a subtle distinction between using import foo and from foo import bar, where when you say import foo, you get the name foo in your available, and then foo is a namespace that contains all the exported functions, variable names. But when you say from foo import bar, then you get the name bar in the foo into your own namespace.
Yeah. So yeah, I don't want to go into these details right now.
Okay.
So the next thing I want to show you is kind of the core data structures that we have available. And so there's essentially, there are kind of the basic data structures like integers, floating point values, complex numbers, and strings, which I'm going to show you in a second. But then Python also has some more advanced data structures like lists, tuples, and dictionaries, right? And I want you to know these because they're going to be used essentially in every single Python program. So it's important to be familiar with them. So let's start with strings. So if you create strings by wrapping the characters that you want to have as a string either with a single quote or double quote, right? You can use either in the equivalent. Now, if sometimes you want to have a string that spans over multiple lines, and the way you do that is you use a triple single quote or a triple double quote. right? And that string goes then all the way up to the point where you use a triple double quote again. So once you have a string, you can create new strings by gluing them together. And funnily enough, you use the mathematical operation to do that, right? So you can use the plus and the star operator to glue together strings. So for instance, if you have the string hello and you multiply it by 3, you get a new string that contains hello, space, hello, space, hello. And then you can add the string world to it at the end, and you get the final string will be hello, hello, hello world. So this even works if you have variables in these operations, right? Let's say we're, what is he called? Not Homer Simpson. What is the small Simpson called, who always has to write these? Bart Simpson. I never had a TV. So you know, Bart Simpson, he always had these quotes, and he had to repeat them. So let's say we are Bart Simpson, and we have to do that, but we have a computer. So what we will do is we write down the quote once, and then what we do is we take the quote, add a comma space, multiply it by 10, and then add the quote once more, so that we don't have a comma at the end. And so the output will be the work that Bart Simpson had to do over a long time. So another important thing that we often want to do with strings is to extract parts of that string, so substrings. So how do we do that? There's a special syntax in Python, and that's called indexing. So what you can do is after the string, you use the index notation, use the square brackets, and you state which position you want to have the substring started and the position of the end of the substring. And so you can use positive integers to start indexing from the left, but you can also start negative indices to start indexing from the right. So to make this concrete, let's say we have this string which just contains the word chips. And so now if we dissect this word chips and we count the indices, right? So this is how it works from the left. So the first character has the index 0, the second character has the index 1, 2, 3, and 5, and so on. Right? But we can also index from the left, where we have, if we want to get the last character, we index at -1. If we want to get the second last character, we get index at -2, -3, -4, -5, and so on. So for instance, if I now use this substring notation and I write string, square bracket, 2 to 5, right? So if I look at my diagram here, the index 2 starts here and all the way up to 5. So I will get the characters IPS. I should get the character IPS if I execute this. So we can test that. And indeed, IPS.
You can also remove the 5, then it will take to the end of the string.
Yeah, so that's a good point. So you can, if you don't specify an endpoint or starting point, it will automatically index all the way to the end. And if you move it at the beginning, it will start at the beginning.
So if
and so
you
here,
want to make a copy of a data structure, you can write square bracket, colon, square bracket.
Yeah. And so here's an example of the negative indexing. And so here we index starting from 1 all the way to -2. Right? So we should see HI here. So let's just verify that that's correct, and indeed. Okay, and so that you will see all over the place in Python programs. And so for instance, this notation, right, if I just use string, square brackets, colon, close bracket, what will I get if I execute this?
The whole word.
Yeah, so this will just give me the entire word, right? Chips. Because Python implicitly, because I haven't specified a start point and no end point, so it will implicitly start at the beginning and end at the end. So I just get the full string back. Okay, so I've created some cheat sheets for you, so we don't need to go through these in detail, but if you're looking for a specific function for strings or for tuples and so on, you can look at these cheat sheets. So essentially, they are kind of very common functions that you use on strings, and this is what they do. So just to give you one example, well, I mean, these are kind of maybe boring. So quote.lower converts the string into lowercase, the same thing for uppercase. So one thing that is often used in practice is the quote.strip method. That just removes any new lines and white spaces at the beginning and the end of the string. So that's often, imagine you're downloading something from maybe a website and you want to just remove, or the user enters a password, let's say, right? And so, of course, the password, often you just remove the white spaces at the beginning and at the end because it's not part of the password. Another really useful function is this quote.split method. And what that does, it takes the string and it splits it at the white spaces and returns a list of items. So let's say you want to do, the user enters a string and you want to do some operation on each word in that string. What you would do is you kind of split up that string into substrings, separate by white spaces, and then you call the operation on every word. So the next important data structures are lists and tuples. And they're actually very similar, so I'm presenting them at the same time. The idea of lists and tuples are they allow you to group objects together. Right? And so, for instance, that's exactly what the name indicates, right? A list is a list of things, right? And a tuple is also kind of a list of things. So here's how you make lists. You say my list equal, and then you use the square brackets, and then you list the items that you want to have in that list. Right? So I have hello as a string, world as a string, exclamation marks as a string, and then I have a Boolean value here, true. And so note here that I can use different types of variables in my list. So Python allows you to mix types in lists. And so a tuple is created in a very similar manner, just that you use round brackets instead of these square brackets. And in fact, there's an alternative notation that you will see sometimes, and you can neglect these round brackets, and what you end up with is just my tuple equal, and then a comma-separated list of objects that you want in the tuple. So if you see this notation here, it means that it creates a tuple in this case. So, of course, the obvious question to ask now is, well, what is the difference between the two, between a list and a tuple? And the difference is that lists are mutable and tuples are unmutable. And so what does that mean? Mutable means that you can mutate the object or change the object after it's created. And unmutable means that once it's created, the values of that object remains the same over its entire lifetime. So the way you demonstrate that, or I demonstrate this, is once we've created our lists, with lists, what I can do is I can write my list of 2, so I index the third item in my list, and I assign a new value to it. I set it to 13. Also, what I can do is I can write my list.append 14 to add an additional item to the end of my list. Right? So these are all mutation operations that change the list. So if I try to do the same thing with a tuple, I would get an error. And so as an exercise, what you could do is you could try, all these operations here, they're actually all, you could try this on a string. If you had a string and you write my string the third character in that string, right? So if you write, if my tuple is actually a string, and you use this notation here, you would get the third character of that string. And if you try to assign a new value to that string, see what happens, and check if strings are actually mutable or unmutable objects in Python. Okay, so the reason why I explain this to you is because we will come back to that mutability and unmutability in a second. So what can we do once we have tuples and lists? Well, many of the operations that we know already from strings also work on tuples. Because so a string is essentially just a list of characters, right? So for instance, if I want to get the first item in my list, I use this indexing notation. My list, bracket 0, close bracket, get the first item. The same thing works for the slicing that I explained before. So let's say I want to get all the items in my list starting from the first one, from the second one, because I start indexing at 0. So from the second item all the way to the end of the list. So I don't specify an end here. Right? Then I get world, then my exclamation marks, and this Boolean 2. And in fact, you can also use this concatenation strategy that that Bart Simpson used to create his quotes. So if I have a list, I can use the plus symbol to attach new items. Well, in fact, this actually creates a new list. But I take my list and I add a new list to it. And so that new list contains of a single item here, the exclamation mark, multiplied by 3. So the result of this multiplied by 3 operation is a new list that contains the character exclamation marks 3 times. And then I have this add symbol here. Then I have the addition here as well. So what you end up with is hello. So you end up with a long list here with hello world, exclamation mark 2. So this was my list. And then one exclamation mark, a second exclamation mark, and a third exclamation mark. Right? That's the result of this last operation here. Is that clear? Yeah. Okay. So then, of course, we have a cheat sheet. We can have a quick look. Can we? Maybe? No, maybe not. What do I want to highlight? Maybe del A3 is an interesting one. So here you remove an element from your list. So your list becomes shorter. You can, another very common one is len of A. That gives you the number of elements in that list. And also this testing if a value is contained in the list is a very common one, right? So if you want to check if the string value is an item in your list, you just write single quote value in A, where A is the list. So yeah, you can look through this when you need a specific function. And then for tuples, it's the same thing. And if you compare the two, you'll see that essentially most of the functions are equivalent. It's only that tuple has fewer functions, namely all the functions that perform operations or that mutate, that would do a mutation are missing in tuples, right? So, for instance, assignment doesn't work, or this del is not part of here, right? Because it would mutate the object, so it's not available for a tuple. So then we have control structures. The very basic ones is of course an if statement. And the way this works, well, here's an example. So let's say we have an integer I here, and we want to behave differently depending on the value of I. So I write if I is smaller than 0, colon, and then I have the commands that should be executed in this case here. And then I use the elif to go into the next case. So I check if I is between 0 and 5. And then I have an else case that is executed if none of the conditions before evaluated to true. So one really important point here is that in Python we don't use the way you define blocks, the commands that are part of an if statement, right? They're called blocks. In C or C++, you often use these curly brackets to define when the block starts and when the block ends. In Python, it's actually defined by the indentation. So you can see that all the commands that are part of that if statement, I've added some white spaces here. So I end here with a colon, and then I add white spaces. So all the commands that should be part of that if statement are indented to the right. And so the same thing is here, right? So I've added 4 white spaces here and 4 white spaces here. And so you need to do that. So if I execute, so you'll see that this runs just fine. But if I would remove these white spaces, and if I would just write the code like this, I would get an indentation error, because Python expects me to indent the at least one command after the if statement to the right. And so normally, kind of the Python default is that one uses 4 white spaces here. And so you can ask, well, why does one do this? And why don't we just use curly brackets, right? That gives a bit of freedom. Yeah, you can. Well, you should set your, OK, so in your editor, you can use tabs. The problem is that if you start mixing white spaces and tabs, right, then it might look really messy if you open up your file in a different editor, and so the definition of the width of a tab is kind of not standardized. So some editors use the space of 4 spaces for one tab. Other editors use 8 equivalent spaces for one tab. So what I would recommend in practice is that set up your editor such that it replaces one tab with 4 white spaces. And then you can indent with the tab. That's what I do. Does it make sense what I'm saying? Yeah, OK. So the reason why Python introduced this syntax is because it forces you to be more clean, right? You have to be consistent in the way you write your code, but also how other people write the code. Right? So you can't. I mean, it would be quite messy, right, if I did this.
I once read a code with Pascal, a language similar to Pascal, and the person had written every line starting from column 1.
Yeah.
A while begin, and then every line started from column 1.
Yeah. So I just want to show you here that this also is true if you nest if statements, right? So here, if you have an if statement, I indent once, right? And then inside that if statement, I have a second one, right? And so of course, I just have to indent once more. OK, just for you to be aware of that. Right, so this still works. So then we have while and for loops. And so now it's also important to loop over items. So the while loop is used if you have a condition and you want to loop over that condition until it becomes true. Right? So maybe you have a counter, right? And you keep counting that, you increment that counter, and you want to loop, and you want to increment the counter until it hits a certain condition, right? So maybe as long as the value of I is smaller than 10. And so the syntax is very similar to the if statements. You use while, and then you add the condition, colon, and then the block of statements indented again. Another loop that you will find actually much more often than the for loop, than the while loop, is the for loop. And the for loop is used to iterate over items in anything that is indexable, right? So for instance, if you want to loop over all the items in a list, or if you want to loop over all the items in a tuple, or if you want to loop over all the characters in a string, what you can do is you write for element in the indexable object. So for instance, a list, right? And then in here, again, you can indent. And what will happen is that this variable element will be available in these statements, in these indented statements here. And this element variable will have a new value every time the loop iterates, right? So in the first iteration, the element variable will have the value of the first item of the list. In the second loop, it will have the value of the second item of the list, and so on and so forth. Right? So for instance, if you wrote for element in some list, print element, it will print you all elements in the list. So one example, we have a shopping list, and we build a shopping app, and someone adds all the items that we need to shop. So tea, butter, and milk. We add that in a list, and then we add we use a for loop to present all the items that need to be bought. So for item in shopping list, and in this variable item here, this is arbitrary. You can say whatever, you can come up with a suitable name. And then inside here, you now can make use of this variable item. So you can print, remember to buy placeholder, and then I place the value of item in here. And when you execute that, well, you already see the output, but let's just test it again. Right. So you get remember to buy tea, which was the first item here, butter, which was the second item, and milk, which was the third item. Exciting, huh? Okay, let's have a break and let's start again at 1:15.